Good evening. Today, I'll, today this tutorial is going to be about how to loop instances on a curve, like in this example. As you can see, the instances go all around this curve and back. This is going to be very handy for any sort of Blender project you want to do, something special like this, or anything else, frankly, for it. Wait a minute. Yep. I hope that this tutorial is going to help someone. But now let us begin. All right, that's it. Okay, sorry about that. That's the first time I ever opened that menu. Now let's begin by pressing A to select everything, and then pressing X to delete everything. Now let's instantiate the curve. Go Shift A, curve, Bezier curve, or any kind of curve you want. Now we're gonna pull this up. Go over here. Go to the Geometry Node Editor tab. Click on new, call it whatever the hell you want. Wow, let's call it wow. All right, grab it all the way over there. Let me check this because I'm gonna need it to be organized while we're working. It's not gonna be organized after we're done, I'm telling you that, but we're gonna try. We're gonna press Shift A, go to curve, and then we're going to resample the curve. Now the way I want to resample my curve is by length. Now this says that every 10 centimeters there's gonna be a new, let's say, vertex on the curve. And on that vertex, our instances will go. Now let's take let's pull out this instance on points node, and then we're going to bring a mesh primitive. The mesh primitive is going to be cube, just for demonstration. I'm not gonna go with a cube, but it's just for demonstration. Let me scale it down a bit. 0.08, I guess, because there are 10 centimeters between each instance. So 8 centimeters for each instance is gonna be all right. And now we want to bring this over here a bit. Yeah, let me bring these two like that. G, X. Okay, good. I'm gonna use a sample curve node. Now the sample curve node, what it does, it takes a certain information from a curve according to its factor. Now a curve's factor begins from 0 and ends at 1. 0 is the beginning, 1 is the end of the curve. So we're gonna shift, right click, pull this one all the way over to there, grab it like that, and we're gonna you go to geometry, set position. We're gonna pull this position socket to this position socket. Now what does that do? It's gonna put all of our instances on that singular point according to the factor of the curve. So when I pull the factor from 0 to 1, it's gonna go from the beginning to the end, just like that. Now let me grab those, grab on the X, grab this one with them, grab on the X. Now there are multiple ways of doing this, looping instances on a curve, that is. Uh, Now, I checked out some videos on YouTube and all that, but I didn't understand any of them. So I came up with this. Let's hope I came up with this. No one came up with it before I did. I haven't seen any tutorial that does what I'm about to do here. So what we're gonna do is we're gonna use an attribute statistic node. I'm gonna put it right here. Now the attribute statistic node, along with the capture attribute node, gonna put it like that. Well, now the capture attribute node, we're going to want it to capture an integer and that integer is going to be on each instance. Now, what's the sort of input? Let's say that we're going the attribute that we want to get from each instance. We want to get the index of each instance. We're going to go to input, index, right over here, like that. And then we're going to use the attribute statistic node to get the amount of instances on our curve. I'm gonna put it right here. Now you can choose integer on capture attribute, but you can't do the same thing to the attribute statistic. I don't know why, but the attribute statistic can only take float and curve, but it does actually take all the other types of geometries or things like that that works with it. So we're gonna set set this one to integer n instance. I'm gonna take the max of this. So the max of this is going to be the highest value of all the indices, like the last value, like the last index of all the instances. Like if there were 20 instances, the max is going to be 19 because the index starts from 0 to 19 if there were 20. The same thing for 100, from 0 to 99, stuff like that. Now we're going to divide the number 1. I'm going to go to utilities, math. We're going to divide 1 over the max, like that. And then we're going to take this right here and shift D, X to grab it over there, and then multiply this value by this attribute. Let me shift right click like that, and then shift right click over here. Now, what's that gonna do? Now, we're gonna put this right here over the factor. This is going to do nothing special at all. It's gonna rearrange the instances on the curve like we literally have done nothing. Like, let me mute this. No, wait, mute both of these. It's like we've done nothing. But we now have control over them, more over their positions for each of them. Allow me now to demonstrate. Grab on the X, GX, and then I'm gonna do Shift D, add. Now look what this does. Now they're moving along the curve, but they're not looping. Like they go all the way to 0, and then like when we set this to 1, add 1, oh, they're all gonna go to the end. We're gonna set this to 0. They're all evenly distributed. And then we go to -1, they're all at the beginning, at 0. Now, how are we going to loop them? Now, the answer to that is very simple. I'm gonna Shift D the math node, put it all the way over here, and then we're gonna use fraction. Now, fraction, what does it do? It's like modulus. It's like the modulus this thingy node. It resets the number, you can say. Let me put a driver on this just to demonstrate by 1200, I guess. Yeah. Now excuse this one. There's some Z fighting going on with these two instances. There are two instances on the same spot at the same time. Now the way to fix that is easy. You need to realize the instances and then use merge by distance node, and they will merge together. And then there won't be any extra vertices or data, let's say, that you won't need. Now, but we don't have to worry about that for what we're gonna do with this node group. Now, Allahumma salli Muhammad. Now we did this. Now what we're gonna do now? We're gonna do next. We are gonna do what I just showed you at the beginning of the video. Now the way I did that at the beginning of the video is quite easy, bit complicated, but a bit easy at the same time. We're gonna get rid of this. I'm gonna pull out a mesh primitive of type grid. I'm gonna put it all the way over here, and then we're gonna rotate it on the Y by 90 degrees, so they're all straight like that. And then we're gonna make those two vertices, so it's gonna be just one square on each of them. Here's in wireframe mode, is three. We don't want that. Here's two. We want that. Now I'm going to scale them a bit. 0.08 like the last one, I guess. Okay, 0.08. Now we're gonna pull it all the way over here and then get out of the wireframe mode. We're gonna realize the instances. Now first of all, I wanna distribute points on faces for each of them, but that's not gonna work. They're gonna have the same amount of points. That's not gonna work with me. So we first need to realize the instances. Now we realize the instances just so Blender doesn't treat them like they're, let's say, a singular instance, like a copy of one instance. It's gonna treat them like geometry, like they're all part of a geometry. Now this amount, I say 1,000 is good enough, I guess. Is that too much? No, it's good. Now let me go to edit mode and delete this curve because it looks lame, frankly. Go here to this pencil. Gonna draw our own curve. Yeah, that's good. Now we're gonna display now before the realize instances. Let me skate on the X, this one, and then gravity on the X. Before we realize the instances, we wanna introduce some what's called displacement for each of those instances. Now, if you do this displacement right after the realization of the instance, it's gonna treat like it's a single geometry and all of that. It's gonna put each vertex of each instance in a different random place, and I don't want that. I want I want each instance to move without it deforming and all that sort of thing. Now we're gonna take what is it? Geometry set position. I'm gonna do a simple setup for it. I'm gonna pull out the noise texture. Now, when I put this noise texture in the offset, you're gonna see that our curve is down here, but our instances are up there. So how do we fix that? It's quite easy, frankly. You just gotta pull out the math node, a vector math node in the vector thingy, vector tab, and you gotta subtract zero point 0.5 from it. So minus zero point 0.5, because I have it on add. I have subtract, I just write zero point 0.5. All right. Now, we're gonna also add something else to it. We're going to add a scale. I'm gonna duplicate this vector math and put it to scale. Now, the scale is very easy. What it does is that it takes the instances, it takes the offset from the noise texture and it scales it up. So let's say you want them to be a bit more uniform. Let's set the scale to 1. Now you all know how a noise texture works, I hope. Uh, it, it displaces everything randomly when you're using geometry noise. If you're using shader editor, it's for something different, like roughness or something like that. But this is what it does. Now you want when I put this scale to 1, it's going to be, a bit weak, but they're a bit more uniform, randomly uniform, let's say. But I want to set it to 4 because 4 looked good. This is what I want. Now, why I put planes on each of those, the instances as planes, and then set the points on the planes, because I want to keep this uniform-like shape of the curve, of the instances moving along the curve like that. I want to keep it. So, afterwards, you guessed it, we're gonna may put our own instances on the curves, on the points, I mean. So we're going to instances, instance on points, And the instance we're going to use is going to be a mesh primitive of type icosphere. Put it right over here. 0.08, I guess, like last time. Bit too close to each other. I think the displacement that we're gonna do to them later is gonna fix all of that. Now, let's do the same thing over here. We're gonna Shift D, duplicate all of these. I don't know why that set position didn't go along with them, but there we are. Gonna put it over here, and then plug the instances to this, this to this. Now, hmm, let me increase the scale, but decrease this scale. Alrighty then. I think I should have made them a bit more smaller than that. I should make make the scale a bit more randomized, yeah. And make it a bit more slower. And go over here. Let's say 2500. Yeah. Now this looks good. This looks really good. Now to make it look like what I made it look like in the project I showed you at the beginning of the video is gonna be very easy. We're gonna to scale the instances. First of all, let me increase this scale because I want more of them be down and more of them up. And then let me put this to 4D, something like that. And play around till I see something that I like. Yeah, I like this. I want them more. I want more of them to be up to show what I'm gonna do to them. I'm gonna put the instances, scale instances node right over here. And then I'm gonna go to input position and then pull out from the position the Z position, the Z vector, I guess you can call it a vector 2. It's within a vector, but I'm not sure actually. I'm gonna use a separate XYZ, put the position here, put the Z over to the scale, and then you're gonna see that these are bigger, even though they are down below. So what should we do about that? We should, now I don't like this. Like number one, I don't like this because this is what happens with it. Like the ones on the down below, or no, they nothing happens to them. I thought they're gonna be inverted enough so all of them are gonna have their normals also inverted. But that doesn't matter. Anyway, I like it this way. I'm gonna keep it like that. Forget about what I was gonna do with them. But what I was going to do with them is going to clamp them using a math node. Utilities, clamp, minimum is 0, maximum is whatever the hell it wants. Let's put it at 10. So not very limited. And then we're gonna grab it on the X. And these two on the X, we're gonna grab them too. And then we're gonna add a math node like that. So none of them is going to be 0. So when the object is 0, it's going to be obviously invisible. We don't want that. We want all of them to be visible. So I'm going to add 0.5 to all of them to their scale. And then I'm going all the way to the what? Where's the icosphere? Here it is. I'm going to subdivide it 2 times or 1 time just for performance sake. And then we're going to we're going to shade smooth them. Go to mesh, set shade smooth. Now this looks way better. This looks way better. But let me go to this scale and let's set it to 4D too. And let's set it a bit lower, like 2.5. It's gonna make them more predictable when they're moving. This looks good. Now, there's something that you might want to do this is very usual when you're using curves, is to scale the instances along the curves. Like using the factors. So at the beginning of the curve, it's zero, so the scale of the instance is zero, but at the end of the curve, it's going to be one, so the scale of the instance is going to be one. But using the method I'm using here, this doesn't work. I don't know why. Let me show you. Wait a minute. Let me grab all of these on the X. G, X, G, X. Wait a minute. This is gonna be annoying. Who gives a shit? Go. Grab on the X. And grab on the X. Right over here. Now we're gonna go to instances. Scale instances. Now I'm gonna mute everything. All of these. I'm gonna press M to mute them. Now we got these planes. Now the planes are not very good to demonstrate that, so I'm gonna put cubes again. Yeah, I should have done that from the beginning of the video, but who cares? There it is. Go over here, please. Thank you. 0.08. Good. Now, you might wanna scale these instances a lot according to the factors. So this is 0, this is 1. So 0 is gonna be in the smallest, 1 is gonna be the biggest instances over here. That might look cool for any kind of project you're doing, but when you're using my method, which isn't very much optimized, you're gonna need to do something else. But let me show you what happens when you do that. So let me go here back to my curve after realizing it. We're gonna do a capture attribute, put it right here. Gonna be float for each point. Gonna go to curve, spline parameter, take the factor, put it right here, and then put this right over here at the scale. Now, as you can see, it's not scaling the way you might expect it to scale. You might want these to be like like the biggest ones go loop around and they still are at the same scale they are, yes, as you can see here, which isn't what you want. So the workaround I made to fix that is quite simple. Control, no, M. Yeah. Actually, can also use cubes, but they're gonna be a bit too, as you can see, a bit too stuck to each other, and gonna have to space them around to make more space around them. So that sort of things. That's why I use the grid here. Let's get our grid back. Now this is good. Yeah. Now we're going to, let me also decrease this. Let me decrease the density on this to make them more spaced up, have more space between them. And then I'm going to decrease the length between each instance. And that actually looks better. Let me make this 5. This looks better actually. Yeah. Now we're going over here to do the thing that I'm telling you about. I'm gonna pull out, I'm gonna create a new collection over here. Right click over here, new collection. I'm gonna call it scale influencers. I'm not sure if influencers is written right, I don't care. Now while this collection is selected, what you need to do is the following. You're gonna instantiate any sort of object that has geometry, mesh, like this UV sphere. Scale it down a bit, and then let's put this all the way over. Grab on the X, and then Shift D, and then grab it over here. Now, as you can see, both of these spheres are in this collection. Let me go back here. Let me pin it so when we deselect it, it's always there. Now we're gonna use geometry proximity. Now all you know what geometry proximity does. It calculates the distance between this geometry between geometries, and then affects the other geometry by that distance. Now we're gonna grab this whole collection, separate children. Now collections are usually all instances. They are always instances. So we're gonna realize those instances so Blender can see them as a single geometry. So you're gonna also put it on relative so it doesn't take the original position of them. And then we're gonna go to geometry, geometry proximity, like that. Faces, vertices, it just doesn't matter. And put out another scale elements node right over here. And then put the distance in the scale. Now, the smaller the distance, the big, the smaller the scale, obviously. Let me grab this on the Z, grab it on the Y, so it's closer to it, as you can see here. So that's the workaround around it. Now I see it as a more versatile way of doing it. For like you can use this distance for lots of things. Like I don't know exactly. You can control like the tilt of the instances and all that stuff. Like you can use the curve tilt. Let me go here. Click W to get out of draw mode. Percent. Like other like geometry nodes thingies. They like to use the what is it? The radius and the tilt of the geometry to make it more controllable, more procedural, more easy. But my method doesn't allow that for some reason because they're gonna move along the curve and they doesn't matter when you move them like along this node graph. They're gonna move along the curve the way you don't want them to. Like that. They're gonna like let's say you want to scale to affect these. It's not gonna work. I tried it. You can try it. You can, if you can make a solution for that problem, that would be very helpful. I would be very grateful for you if you share it down in the comments. Now, this is it for this tutorial on geometry nodes. It was just to help people to loop uh, instances on curves because I kept looking around and I found examples that actually never helped me. Now, I hope this helps people. And the problems that may come with it, I try to solve them by using this method with the geometry proximity, but the geometry proximity is not very helpful, frankly. Like they're all gonna be affected by the distance. Like grab on the X all the way over there, it's not gonna help. It's not going to help. Like they're all going to be affected. Like you want just to affect these at the beginning, but no, the other ones are all going to be affected by. So you're going to have to play around with the maths and stuff like that. But anyway, I hope this video helped you, and yeah, I also hope that you learned a lot from this video. And good luck on learning Blender. Goodbye.